There is a sequence that takes 3 seconds to perform. It costs nothing. It requires no tools, no products, no service appointment. And every time you skip it, you are transferring the entire weight of your vehicle onto a metal pin inside your transmission that was never designed to carry it. That pin is called the parking pawl. And when it fails, when it wears, cracks, or locks under load, you are looking at a transmission teardown, not a fluid change, not a filter, a teardown. Professional drivers know the sequence. Fleet engineers in Japan have been documenting it for decades. Toyota, Honda, and Nissan engineers designed their drivetrain systems around it. It is written into the service manuals for vehicles sold in the domestic Japanese market. It was never communicated to you, not by the dealership, not by the salesperson, not in the owner's manual summary you were handed at delivery. And the reason most drivers have never heard of it is not because it does not work. The parking pawl was not designed to hold a vehicle stationary. That is the first thing you need to understand. Every automatic transmission manufactured in the post-war era was engineered with the same load assumption. The parking brake, a mechanical friction brake acting on the wheels, holds the vehicle, and the park position provides a secondary anti-roll lock for level ground and minor inclines. That is the sequence the engineers designed around. Brake first, park second. The Japanese domestic automotive industry formalized this understanding in driver training and commercial fleet operations beginning in the 1970s, as automatic transmissions became standard in passenger vehicles and commercial fleets. The Japan Automobile Research Institute (JARI) and domestic OEM service documentation consistently describe the proper engagement sequence as part of standard vehicle operation. Toyota's domestic market operator manuals for automatic equipped vehicles have specified handbrake before park as the correct procedure since at least the early 1980s. In fleet operations, taxi companies, logistics operators, delivery services, vehicles are stopped and parked hundreds of times per shift. Fleet engineers identified parking pawl stress as a primary failure contributor in high-cycle transmission wear. The solution cost nothing. It was a procedure change. That is the entire intervention. Here's why that matters to you. The parking pawl is a small, hardened metal tooth. It engages a notched ring attached to the output shaft of your transmission. When you shift into park, that tooth drops into a notch in the ring and prevents the shaft from rotating. The system works exactly as designed when there is no load on it. When you shift into park before applying the handbrake, gravity does not disappear. If you are on any incline at all, even a slope imperceptible to you, the full rolling weight of the vehicle is transferred immediately onto that pawl and the notched ring it engages. The pawl becomes the sole point of resistance between your vehicle and motion. That is not what it was built for. On flat ground, the stress is lower. On a 10% grade with a full-size truck or SUV, you are loading that pawl with thousands of newtons of force every single time you park. Then you return, start the vehicle, shift out of park under that same load, and you feel the transmission clunk as the pawl releases. That clunk is not normal. That clunk is damage accumulating. Now do that 10,000 times over the life of the vehicle. You now understand something that most drivers who bought a car the same week you did are still not doing. They are parking the same way they were taught by someone who parked the same wrong way. The chain of uninformed behavior goes back decades. If this channel has given you something useful today, hit subscribe. Every week, this is the content, real technical knowledge that exists in professional and engineering communities, explained plainly for the person who owns and maintains their own vehicle. But stay here because what comes next is the mechanical science of exactly what happens inside the transmission casing at the moment you shift under load, and the numbers on pawl wear cycles are going to change how you park for the rest of your life. The parking pawl and parking gear are hardened components, but hardness has limits. The contact stress generated when a loaded vehicle settles onto the pawl creates what tribologists call a Hertzian contact stress concentration, a localized compressive stress at the surface interface between the pawl tip and the gear notch that exceeds the stress generated during normal engagement on level ground by a significant margin, depending on vehicle weight and grade angle. Research in mechanical component fatigue, published in Tribology and powertrain engineering literature, documents that cyclic high-contact stress loading of hardened steel components produces surface fatigue failure modes, micropitting and spalling, long before bulk component fracture. The component does not shatter. It degrades gradually, developing surface pitting at the contact zone. which increases contact stress on subsequent cycles, which accelerates further degradation. This is a self-reinforcing wear cycle. The industry term for the load transfer you generate by shifting to park before setting the brake is called a Pawl load condition. Transmission engineers at OEM level design the Pawl to survive millions of correct engagement cycles. They do not design it to survive tens of thousands of loaded engagement and release cycles. That is a different fatigue scenario entirely. The comparison is direct. A transmission in which the handbrake is consistently engaged before shifting to park experiences near zero load on the Pawl at engagement. The parking gear ring receives no ratcheting stress. The shift out of park requires no force. Over a vehicle's service life, the difference in cumulative contact stress on these components between correct and incorrect procedure is not marginal. It is the difference between a component that outlasts the vehicle and one that requires service at 150,000 kilometers. Fleet operators running proper parking sequence protocols as a mandatory procedure report dramatically lower rates of transmission park mechanism complaints and replacements compared to mixed procedure fleets of equivalent vehicle types and mileage profiles. This is consistent with what the mechanical fatigue literature predicts. In high-density urban taxi fleets, vehicles accumulating 150,000 to 200,000 kilometers per year in stop-and-go conditions, transmission service costs are one of the most closely tracked maintenance metrics. Operators who standardized the handbrake first sequence as part of driver onboarding documented measurable reductions in park mechanism service events compared to their prior operational period. The vehicles were the same. The drivers changed one procedure. The vehicles where this matters most are not flat country highway vehicles, they are the ones parked on urban grades multiple times per day. San Francisco, Vancouver, Sao Paulo, cities where every parking event is an incline. If you drive in one of those cities and you are not doing this, you are loading your parking Pawl every single time you stop. A well-maintained automatic transmission in a vehicle that has been parked correctly from delivery will outlast one that has not by a margin that shows up clearly at inspection. The Pawl and parking gear are visual diagnostics. A technician who has opened enough transmissions can tell the parking history of a vehicle from the contact surface condition alone. The procedure is simple. You will change nothing about how you drive. You will change 3 seconds of what you do when you arrive. Step 1. Come to a complete stop. Your foot is on the brake pedal. The transmission is still in drive. Step 2. Engage the handbrake fully before doing anything else. If you drive a vehicle with a foot-operated parking brake, press it now. If you have an electronic parking brake, activate it now. If you have a traditional hand lever, pull it to full engagement now. The vehicle is now held by the wheels, not the transmission. Step 3. With the vehicle held by the handbrake, shift the selector to park. The Pawl engages a stationary, unloaded parking gear ring. There is no clunk. There is no load transfer. The Pawl drops into a neutral load position. Step 4. When departing, shift out of park before releasing the handbrake. The transmission has no load on it at the moment of disengagement. The departure sequence is the inverse of the arrival sequence. Handbrake off after you select a drive gear, not before. This is the complete procedure. It has no cost. It requires no products. It takes 3 additional seconds per parking event. The manufacturers who specified it in domestic market documentation understood exactly what they were protecting. It was never hidden in classified engineering files. It was always in the service literature. It simply was not in the materials given to you at purchase. The dealership equivalent of a parking Pawl and parking gear replacement, when this failure occurs as part of a broader park mechanism service, typically runs between $800 and $2,500, depending on transmission type and labor rate. This procedure costs $0 and takes 3 seconds. This knowledge is not new. It did not originate in a YouTube video. It is in the professional driver training materials used by Japanese taxi and logistics companies since automatic transmissions became widespread in commercial fleets. It is in the engineering documentation that OEM transmission design teams work from. It is applied daily by every driver who was formally trained in automatic transmission operation by someone who read the original literature. It did not reach you because no one profits from teaching it. There is no product to sell. There is no service interval to monetize. There is no replacement part with a margin attached until the failure happens. And by that point, the revenue belongs to the transmission shop, not to the entity that could have prevented it. That gap between what is in the technical literature and what reaches the consumer is exactly what this channel exists to close. If someone you know drives on grades, owns a vehicle they plan to keep for more than 150,000 kilometers, or has ever heard that clunk when shifting out of park, send them this video. That clunk has a cause. Now they know what it is. Next week, the coolant additive that Japanese domestic market vehicles have been running since the 1980s that does not appear in Western market service specifications. And the real Documented reason it was left out of the formulations sold here. If you change your own coolant or you are due for a flush in the next 12 months, you need to watch that before you buy anything. Subscribe. You have earned the next one.